Hello students, now we will see the next experiment, measurement of wavelength of laser beam. As we know, the laser is said to be light amplification by stimulated emission of radiation. The all basic concepts regarding laser that we have studied already in the classroom. So light amplification by stimulated emission of radiation. So this laser beam is said to be a monochromatic in nature always because it emits light with a particular sharpness only in a single color. That's why it is said to be a monochromatic radiation. When this monochromatic radiation falls on a diffraction grating, this laser which will diffract in a different direction. The meaning regarding the diffraction grating, this is the diffraction grating that we have already studied in the theory classroom. Diffraction grating. This is the diffraction grating which consists of 2500 lines. Which consists of 2500 lines per inch. Okay, 1 inch is 2.54 centimeters. So we can easily convert inch into centimeter. So within this 1 inch there are 2500 lines are present on which laser light incident, laser light suffers diffraction from the edges of an slits. Now this is the diffraction grating which consists of number of slits. We know A is said to be slit with the B is said to be opaque portion between two slits, and A plus B is called as the grating element. Also we know grating equation, that is d sin theta is equal to m lambda. M is order of diffraction. This formula you have already studied in theory classrooms. d sin theta is equal to m lambda. Okay. So lambda is equal to d sin theta upon m. This is the diagrammatic representation. When laser falls on a diffraction grating, this you will get see the figure clearly. At the center you will get a direction of incidence. So I can say this is said to be central maxima. Okay. Regarding all diffraction maxima intensity, minima intensity we discussed in the classroom. Central maximum always present followed by minima. This is first minima, second maxima, second minima, third maxima, third minima. So always the central maximum which is followed by number of minimas, and you are going to take reading for number of minimas when laser suffers a diffraction from this particular diffraction grating. So first we are going to discuss least count of this meter scale, that is observation. This meter scale which is used to measure minimum scale, okay, 0.1 centimeter. This scale is used to measure the 0.1 centimeter, that I can say minimum count of the scale is said to be, least count of the scale is 0.1 centimeter. This is first observation. Now distance between source and screen. This laser acting as a primary source of light, and this is the grating acting as a secondary source of light as per hygiene secondary wavelengths theory. When primary light incident on diffraction grating, each point of the grating acting as a secondary source of light as per Hygie's theory, and when light diffract from this diffraction grating, the diffraction pattern observed on the screen followed by central maxima, okay, first maxima, first minima on one side, on the either side, first maxima, first minima, followed by again second maxima, second minima on one side, second maxima, second minima on either side. So whatever the pattern is observed on left hand side, the same pattern for maxima and minima which is observed on the other side. So let us check whether the laser light which is producing diffraction pattern on the screen or not. This is laser source given to you. The construction and working of this particular laser source. This is the laser source, okay. The construction and working of this particular helium neon laser source we have discussed in the theory classroom. I will switch on the source. Second observation is keep the distance between screen and source, secondary source, as a fixed distance. I can say the fixed distance is said to be 26 centimeter. This is second observation. First observation is least count, it is 0.1 centimeter. Second observation is said to be distance between source and screen, it is said to be 26 centimeter. And we know if 2500 lines are present, number of lines capital N, we know the relation grating element and number of lines, D is equal to 1 upon n. So 2.54 divided by 2500, you will get the grating element. This is third observation. First observation, least count of the scale. Second observation, distance between screen and source, secondary source. And third observation is 2.54 divided by 2500, you will get grating element of the particular diffraction grating. So let us check whether you will get here diffraction pattern or not. Of course, yes, you can get. I will just make 16 close to this particular diffraction pattern. Now see, this is the diffraction pattern produced on the screen. It is exactly visible to you now. See, you are getting number of minimas. Okay. Here is said to be central maxima. You can easily see this is the central maxima. First minima on one side, first minima on other side. Second minima on one side, second minima on other side, third minima on one side, third minima on other side, fourth minima on one, fourth minima on other side, fifth minima, sixth minima, fifth minima, sixth minima. Now see, central maximum diffraction pattern followed by first minima, second minima, third minima, fourth minima on one side, same followed to the other side. Now we are going to measure distance between the minima on either side, that is from LHS as well as from RHS. This distance from central maximum, I can say this is the central maximum. Here is first minimum on one side, first minimum on other side for first order diffraction. Second minimum on one side, second minimum on other side for second order diffraction. Third minimum on one side, third minimum on other side, third order diffraction. Fourth minima, fifth minima, and sixth minima. The pattern would be like this. The pattern would be like this. This is central maxima, first minima, second minima, third minima, fourth minima, fifth minima on one side, that is LHS, and first minima, second minima, third minima, fourth minima, fifth minima, and sixth minima on other side. So you can see the diffraction pattern. Once again I can show this. Okay, so this is diffraction pattern made by the laser when it diffracts from the diffraction grating. Now we are going to measure the distance. On one side, I will measure distance as a R1, that is on RHS, and on LHS I will measure the distance as a R2. So you are going to measure distance like this. See, on RHS reading is said to be R1, distance of first minima from central maxima. On LHS, distance of first minima from central maxima is said to be R2. So measure R1 and R2. Using meter scale, I can measure R1. R1 is said to be 2 and R2 is said to be 1.9. Not needed. Both readings should have same values. R1 and R2 should have same values. This is said to be 2 cm and this is we got as a 1.9 cm. No need to see whether the readings are said to be same. Here I got values, it is said to be 2 cm. Here I got the value said to be 1.9 cm. Now continue the same procedure. R1 for second minima, R1 for third minima, same. R2 for second minima. R2 for second minima, R2 for third minima, R2 for fourth minima. Okay, I think you can see here. RHS, R1, LHS, R2. So R1 on RHS, R2 on RHS, LHS for first minima. Second minima, R1 on RHS, R2 on LHS, second minima. Third minima reading, R1 on RHS, R2 on LHS, third minima. So like that, you have to note down the reading for R1, R2, R3, R4 for number of minimas. So how to write these minimas reading? I can show here table. This table I will provide you to your email ID. Order of minima. Just I have said here, order of minima are said to be order of minima 1, 2, 3, 4, 5, 6. I have taken the 6 minima reading here. And here you have to write the R1. Here you have to write R2 for first minima. If here is a 1, first minima, R1 on one side, R2 on other side, 2x is equal to R1 plus R2. So x mean distance, because you got R1 on one side, you got R2 on other side. Average value is said to be x is equal to R1 plus R2 divided by 2. Okay, and theta is said to be x by d. This x, this is your calculated value divided by d. Capital D is what? Distance between source and screen, that we have already measured. It is said to be 26 into 180 by pi. You will get in a degree. It's a sin theta, and wavelength of that laser source lambda is equal to d sin theta upon m. D is what? Grating element. Earlier I just discussed about 2.54 divided by 2500. You will get grating element is said to be d into sin theta upon m. M is what? Order of minima. It is said to be m. M is said to be order of minima 1. For second order of minima, note down R1, R2. Third order of minima, R1, R2. Fourth order minima, R1, R2. 2x is equal to R1 plus R2. X is equal to R1 plus R2 divided by 2. You will get theta. Get the theta for all these minima. Sin theta for all these minima. Lambda for all these minima in a centimeter. You will get average wavelength 5700 near about into 10 raised to minus 8 centimeter. After getting this mean value wavelength, how you got this value lambda? Lambda is equal to d sin theta upon m. Now we are having the value of sin theta. We are having the value of order of minima 1, 2, 3, 4, 5. For order of minima 1, 2, 3, 4, 5, we are having the values of sin theta 1, 2, 3, 4, 5. Later on I will provide the readings also. Plot the graph sin theta on y-axis, order of minima on x-axis, you will get the slope. But sin theta upon m is what? Sin theta upon m is what? It is said to be slope na. So slope into d, you will get, see here, slope into d. What is the slope? Sin theta by m. See here, sin theta by m. If you multiply this slope by d, you will get again wavelength. So d into slope, you will get the wavelength of laser by graph. And this is the wavelength of laser by calculation. So by calculation, wavelength of laser is near about 5700 angstrom, and by graph, the wavelength could be in a good agreement, maybe 5800 angstrom, maybe 5600 angstrom, but it should be in a good agreement. This all AM apparatus formula diagram, observation table, all these concepts and these observation table, calculations, result, procedure, okay, I will send as a soft copy or PDF copy as a soft copy to your register mail ID. Then you have to note down the readings, because I am going to provide the readings to all the students. Readings means just I have taken a sample reading here. R1 for first minima, R2 for second minima, R1 for second minima, R2 for second minima, R1 for third minima, means you have to note down the reading from center to the third minima, center to the third minima. Likewise, I will provide the readings to all the students. You have to do the calculations and you have to calculate the wavelength of laser using diffraction grating. Once again, I will show you the diffraction pattern here. See, center maxima, first minima on RHS, first minima on LHS, second minima on RHS, second minima on RHS, third minima on RHS, third minima on RHS, fourth minima, fifth minima, fifth minima. Just note down the reading from central maximum to first minima RHS, central maxima to second minima, first minima LHS, central maxima to second minima R1, central maxima to second minima R2. Likewise, I will provide the readings to all students. You have to do the calculations and result only. Okay? So we can stop here. Thank you.